G'day, welcome back. We're looking at displacement and velocity with kinematics. Last video we looked at all of the introduction to kinematics and what's involved with calculating integrals with kinematics. This lesson we're going to be looking at, or this video we're going to be looking at an example question. So let's get straight into it. We'll look at it in terms of the way we can do it with a motion diagram, and then how we can do it without the motion diagram with graphs and using algebra. Alright, so let's get this in the first place. First thing is here is find the total distance travelled in the first second of motion. So we've got this function up here. We need to find out the total distances travelled. But before we can do that, we're going to have to try and find any turning points. So let's look at 1. Let's find all the turning points. So 1 minus 2t is equal to 0. We get negative 2t is equal to negative 1. So therefore, t is equal to half. So we know that from this function that after half a second, our particle is going to be changing direction. So we can prove this and see if it is actually changing to the left or the right by using a sine diagram. So if we plug in a sine diagram here, where we've got 1/2, all we're going to check here is, okay, let's choose a number that's less than 1/2 to plug into this function. So let's check 0. If we put 0 in there, we're going to get a positive, and if we put something greater than that, we should get a negative. So we now know that it does actually change direction. So it's going in a positive direction until it hits half a second, then it goes backwards. So we've got something that kind of looks like this. So at t is equal to half a second, and we've got t is equal to 0, it's at this point that it changes direction and then goes backwards, according to what we have for our sine diagram. So we want to find that total distance travelled in that first second. So what we also need to do now is, in order for us to find that distance travelled, we have to work out the positions at different points of time. If we look at this here, well, what that means is I'm going to have to integrate my velocity function into the displacement function. So let's do that here. So we've got 1 minus 2t dt. Notice I don't have any values on there yet because I don't have the points I need to find. Well, I don't have the lower and upper points. I'm finding what the displacement function is going to be. So if we integrate this, we should get t minus 2t squared over t plus c, which then is equal to t minus t squared plus c. However, when we're looking at this function here, we know that initially t is 0. Okay? And we get 1 second. So therefore we get c is equal to 0. And if c is equal to 0, then we don't have any other value. So this here then becomes our function, t minus t squared. So that's what x of t is going to be. Let's tidy that up, it's a bit messy. So now we have our function. We can now substitute our 3 points. 0, so we're going to have x of 0, x of 1/2 because it changes at that point, and our finishing point is at the end of the second, so x of 1. So if we plug 0 in here, and we'll put plus c here, if we plug 0 into this, we're going to get c. If we plug 1/2 into this, we get 1/2 minus 1/2 squared plus c. So we get 1/2 squared, so that is equal to c plus 1/4. So there is our second point. And if we plug 1 into it, we end up just getting c again, because it gets 1 minus 1 equals c. So we've got our 3 points, but that doesn't do anything for me. It doesn't tell me that total distance. So I can use a motion diagram now to help me work out that answer. So what do I know? We started our motion diagram before. We're starting at c, and c was when t is equal to 0. We're traveling along all the way up here. I know that at t is equal to half, that I'm changing direction. And I know that at t equals 1, I'm finishing. I'm just looking at it when it gets that first second. So what I don't need to put in here is that when t equals a half, we worked out that this here is equal to c plus 1/4. And when it goes back, we're going back towards its c value. So what we have here, if we're going to work this answer out, we would have c plus 1/4 minus c. So we're finding that distance between these 2 points. And because we're coming back to c, we will add on to that, well, c plus 1/4 minus c again, because that's the distance between these 2 points. And what you should see is these two will cancel out, and I'm left with 1/4. These two should cancel out, and I'm also left with 1/4. So therefore, the distance travelled is 1/4 plus 1/4, which is it's travelled 1/2 centimetre. Okay, so we can see that this particle from where it started initially has travelled a quarter of a second one way, and then a quarter of a second the opposite way after it's turned after 1/2 second, okay, and it's returned to where it's gone after that first second. Okay, so a quarter of a centimetre, at 1/2 second, it's come back another quarter of a centimetre for a total of 1/2 centimetre. So a lot of that work just to get to this point. Let's have a look at part 2. So we'll look at part 2, and then I want to show you another way of doing the distance, just so that way you can see that with a calculator or with the absolute values and using integration, you can get that same answer. So displacement, we want to find the displacement over the second. Well, displacement, remember, was x of where we started minus x of where we finished. Well, we only go for 1 second. We started it when x was equal to 0, and that gave us c. And where we finished was after 1 second, which gave us c. So therefore, c minus c will give me 0. And that made sense, because remember when we had that motion diagram, we started here and we finished here. Exactly what we spoke about in that introduction video. So the total displacement over that second is, well, it hasn't been displaced at all. It's just come back to where it began. Let's come back and have a look at finding the total distance a different way. Okay? If we were going to graph y of 1 minus 2t, so let's just graph that and see what it looks like. So we're coming through, so 1 minus 2t, let me see, going through a negative here. So for the first second,